hello, everybody. I wanted to. I know that we've been talking about the Internet of Things for a couple of hours now, but I wanted to step back a little bit and have a conversation about Internet of Things reality check. As a way of introduction, my name is Maciej Kranz. I run strategic innovations at Cisco. Been involved in IoT for, well, I think probably 14 years now. I actually wrote a book about it that has been being translated into 10 different languages as well. I know we've talked about IoT again for a couple of hours, but I just want to make sure that we're on the same page. Internet of Things is about everything getting connected. So cars, in 2 years, every new car will be connected. Buses, trains, buildings, assembly lines, all fields, even trash bins are getting connected to each other, to the internet and to the networks. However, if you look at the sort of a first phase of internet, if you think about us using these connected devices, the main purpose of these devices is to give us people access to each other, access to the online processes, access to online data. The purpose of IoT devices is very different. Their main goal is to generate the data, and then we can use this data to create solutions and to create business outcomes that can drive improved operations and start transforming businesses. So, if you think about our discussion here over the next hour or so, if there's one takeaway that you take from this conversation, it is that Internet of Things is not just a vision, it's not the future, it is here, it is now. There are literally tens of thousands of companies that have either been implementing IoT or that have been participating in putting the solutions together. But it's probably fair to say that over the last, especially I would say 6 years, we've seen a lot of IoT hype. I'm sure all of you have seen these huge numbers. There are billions of devices getting connected. There are these trillions of dollars that all of us will make as a result of implementing IoT. Probably my favorite is if you go to a consumer electronics show and you see things like connected fridges or connected toasters, and you sort of start scratching your head. But the reality is that Internet of Things is actually not about all of these numbers, big projections. It is about these. Yes, boots, but more importantly, people that wear them, the frontline managers, the line of business executives. But these folks actually don't care much about technology. They actually care about business outcomes. They care about quality, productivity, uptime or downtime, efficiency, the business metrics. And over the last couple of years, and I think we all a bit of at fault here. Over the last couple of years, a lot of the messages coming from the industry have been focusing on sort of technology, and they've been going over these people's heads. They've been often confused about discussions about gateways and different protocols and so forth. They really wanted to focus on what IoT can do for me versus what are components of IoT. So from that perspective, what I wanted to do is maybe over the next 10 minutes or so, to invite you to walk in these people's shoes and to see how they are starting on their IoT journeys and what were the first projects that these companies have implemented. I've actually worked with dozens and dozens of organizations over the last couple of years in different geographies, in different industries, from industrial sectors to healthcare to agriculture to smart cities. But it was fascinating when I started to think about all of these different companies and started to sort of categorize what were the first projects that they used to get started on their IoT journeys. They actually fell into sort of 4 different categories, and they're listed here on the screen. There are connected operations, remote operations, predictive analytics, preventive maintenance. Let me give you some examples. So connected operations. So Harley Davidson, we all know Harley. I'm not a biker, but obviously I know the brand. And before IoT, I sort of jokingly talk about that they were sort of operating as if they were an archipelago of data islands. So if you look at their plant floors, which of their stations were sort of operating in isolations, many of the devices were not actually connected. And more broadly, if you look at the entire processes, they were not connected either. So a couple of folks in one of the plants got together, and they were from different walks of life. So there were operational technology folks and IT folks, logistics, finance, and so forth. And they said, okay, let's fix that. Let's start connecting our operations. And the problem they were trying to solve is that if you and I wanted to place an order for new configuration, if Harley wanted to introduce new configuration of their bike, and that's sort of part of their value prop, right? Is that they can make this bike special for you. It would take up to a year and a half from the time you would place an order for this new configuration to the time they would actually deliver the product. So this group of folks wanted to solve the problem and accelerate it. So they first started basically putting all of their devices on all the processes in this one plant, on the one network. And then as the data started to flow, they started using analytics and optimization software, orchestration, and so forth to start accelerating processes within the plant. And then after that, they looked at an entire process from ordering to shipping and started looking at automating this as well. And the results were absolutely staggering. They were able to reduce the time to order the custom bike from as long as 18 months to as little as 2 weeks. They were able to reduce the time to troubleshoot a problem on the manufacturing floor. They used to take them days or even weeks. They reduced this time to minutes. And in the process, they improved the bottom line by 3 to 4%. So the second example is remote operations. Probably the most common use case or the application that I've seen across the different industries. Primarily because it's actually a fairly much simpler than the others. And you don't have to implement sort of change across your entire organization. You can implement these kind of solutions very surgically. So let me give you an example, probably one of my favorite examples. This is a 150-store ice cream chain in central India. And the reason it's one of my favorite examples, because it's very powerful, yet simple, but it highlights the need to be hyperlocal. As we discussed earlier, with IoT, the main goal for us is to solve the business problem. Excuse me. And so we need to start with being hyperlocal, understanding the business environment. And you can't just take a technology that was sort of implemented, let's say, in the US and sort of install it in India and hope it works. So in this case, what this company, the problem that we're trying to solve is that in central India, they have power outages and occasionally, and they installed generators in each of the stores. But let's say the power outage happened in the middle of the night, nobody would turn the generator on. Sometimes managers were trying to be sort of frugal and also didn't turn the generators on. So as a result, company was losing money because the ice cream was melting. But more importantly, they were creating a health hazard, because if the ice cream will melt and then it will refreeze, we know what happens. So they turned to a small startup called Nimble Wireless and asked them to help them solve the problem. So what Nimble did, they took a self-contained, a very sort of a simple temperature sensor, and they plugged these sensors into each of these fridges, connected the sensors to the network and then to the communication system. So now, as the temperature would go up in the fridge, they would the manager of the store will start getting messages, and some of them will be the loudspeaker, some of them will be through a text. Sometimes, and that's again sort of this being hyperlocal, communicate with people how they actually prefer to be communicated with, sometimes they will actually get a phone call with a message, hey, the temperature is going up in the fridge. Maybe you should close the door, or maybe there's a power outage. You should turn the generator on. If there's no action and the temperature continues to go up, these messages will get escalated up the hierarchy. It can even reach the CEO if there's no action taken. So again, a very simple solution, but the outcome was very powerful. This company actually, within roughly a year of installing the system, they were able to, they realized roughly 500% return on investment. Another example, and I will give you a couple of more examples. Hopefully you can sort of, to give you a sense of what's going on. So Maersk, the largest container ship operator, is pretty much guaranteed, regardless of where you live, that you would, the goods that you're consuming or you're using most likely have been transported by this company. But the problem the company had was that they actually believe that they're losing roughly $1 billion per year because they are they're shipping empty containers. But they also noticed that on many of their containers, they started to install telematic sensors so that they can actually register, let's say, if you're shipping wine or food, what temperature these goods were exposed to, whether there was vibration and so forth. So they decided to use these sensors and start using them to determine whether the container is full, half full, or empty. And by connecting this, actually in this case, to a Teradata system, they were able to keep track of which containers were empty and start optimizing their use. And in the first couple of months of operation, they were already able to save $100 million. Now let's look at predictive analytics. So in this case, let's look at General Motors and Fanuc. So Fanuc is a Japanese robot manufacturer, and General Motors, I think, is using roughly 30,000 of Fanuc's robots. And initially, before IoT, the way Fanuc would sort of install these robots, they would go in, they would work with General Motors, they would configure these robots for the specific tasks, and then they would sort of leave and just come back if there was a problem. But between GM, Fanuc, and Cisco, Rockwell, and a couple of other companies, they decided, okay, what if we start connecting these robots? What if we start getting the data out of these robots? Now we can start analyzing and looking at trade-offs of sort of longevity and or tiredness of materials versus functions, and optimizing some of these parameters. So they roughly connected half of these robots over the last couple of years. And General Motors is reporting that over the last 2 years, by connecting these robots and implementing what Fanuc calls a near zero downtime capability, they were able to reduce roughly, or anticipate roughly 100 stoppages of their lines. And each of these stoppages, at the system-wide basis, can cost the company roughly $2 million. So you can do the math. A similar example with trains, and I promise we will sort of, this will be just this and the last one example, and then we'll talk about some other things. But in this case, in Spain, the train operators were competing with the low-cost airlines, and they decided to fight back. So they picked a line between Madrid and Barcelona, high-speed rail, and they decided to come back with a competing offer. So they structured the deal, they structured pricing and so forth. But the key to their value proposition was the guarantee that if the train does not arrive within 15 minutes of advertised time, they will refund all the tickets to the passengers. And they were able to make this type of a guarantee because they installed a comprehensive set of sensors, both on board as well as along the tracks. And they were able to keep track and optimize this train going from Madrid to Barcelona. So long story short, by installing this kind of a system, they were able to, I believe, convert in the first year or two, convert roughly 60% of passengers that were using these low-cost airlines to actually choose the train instead. and it resulted in roughly $100 million of additional revenues. And the last sort of most common use cases that are being used to get started on IoT journey is around preventive maintenance. Probably the most impactful use case, but also I would say probably the most one of the most complex to deploy. Preventive maintenance is still very verticalized, but let me give you an example of preventive maintenance in the mining industry. Actually, these capabilities, preventive maintenance, are used in many industries, from utilities to transportation. But I love the mining example because it's sort of it's very visual. So when you think about mine, especially open pit mine, if you ever have a chance to go to, let's say, open pit mine in Australia, it's a big hole in earth, 2 miles deep, 1 mile, 2 miles across, 1 mile deep. And there are these little specks going on the edges, and these specks are actually these huge hauling vehicles that have tires that are actually taller than a human being. And the problem that the companies were trying to solve is that when each of these vehicles breaks down, it costs the company roughly $2 million per day of lost revenues. And before IoT, it used to take days or weeks to fix the problem, because you had to analyze what the problem was, order parts, ship the parts. Again, these mines are hundreds of miles away from the nearest town or airport, and then fix the vehicle. And by the way, the only way of pulling the vehicle out of the pit was to use another vehicle, so you were sort of doubling the cost. So the company started to implement these preventive maintenance solutions, initially using just the regular analytics systems, and by installing the sensors on the vehicles, getting the data, and sort of starting correlating the most common problems. They were able to look at those and anticipate roughly 80% of problems roughly 3 months in advance. But then as they started to use machine learning and getting more data, they were able to actually increase this number to mid 90%. And obviously solving the problem that we've talked about as well. So anyway, when you look at all of these examples, what are some of the lessons learned? So some of the lessons learned, the first one is, yes, have a big vision. So dream big, but start small. Have a big vision, design the overall architecture so that you're consistent. But start with a first small project. Don't get too ambitious, because in some way you are starting on the journey, and it is, and you need to make sure that your first project is a success. For lots of reasons, because of you will have a lot of naysayers in the company. You will have people that would actually be skeptical, even hoping that you would actually fail. At the same time, you have to gain experience working with the systems across multiple organizations and so forth. So pick a small project, have a success, understand the return on investment based on the initial project, and then start building your roadmap and building your journey. Another big sort of lessons learned is have a C-suite sponsor, so a senior management sponsor. Again, for the similar reasons, you are not just implementing IoT technology, you're transforming your company. So you need a senior sponsor to help you and sort of have your back. And then build your virtual team within the company and establish the partner ecosystem externally as well. You know, in the book, I actually have a whole chapter dedicated to failures. And I can tell you it was actually pretty difficult to get sort of early adopters, especially, to talk about failures. And nobody likes to talk about, hey, I failed, isn't it great? But I thought it was so important that we learn from each other's mistakes. Like with every new technology, with a new trend, there will be mistakes. And I'm not going to walk through all of them, but let me give you just one example of probably the most common mistake. And it's so obvious. Too many times, we would see organizations implement IoT solutions in isolation from the business process. So getting sort of excited about technology rather than what problem I'm trying to solve, and how do I change the business process, adjust the business process with this new solution. Let me give you a very, very simplistic example. So in this case, a city in the US, they installed a manhole inflow system, basically to make sure that their sewer system was not clogged. And the system was working as designed, but the return on investment did not materialize. Why? Because they forgot that above the ground, there was a process. Basically, sweepers were going around and sweeping all kinds of stuff into these manholes and clogging the manholes. So when they discovered it, they talked to the sweeping team and they changed the procedures. And the long story short, excuse me. The long story short, then the system started working as designed. I know it's a very simplistic example, but hopefully it drives the message across, which is make sure that you focus on business problem, business process first, and make sure that your solution is fully integrated with this business process. So what are some of the consequences and trends as a result of these Internet of Things transformations? The first one that I wanted to highlight is a transformation of the market structures. So in the technology industry, we sort of used to this concept of companies like Intel, like Cisco, and many others, building very successful businesses based on open systems, open standards. But in many of the more traditional industries, like the industrial sector, for example, the prevailing model has still been, up to recently, the model of sort of one company doing it all, usually a vertically integrated company developing the entire solution. So if you wanted to build, let's say, a train station or an oil rig, you would turn to one of these traditional players, and they will basically design and install the entire train station or oil rig from A to Z using their own technologies or some of the select partners. However, with the advent of IoT, increasingly we started to see that customers were sort of asking the question, why should I be paying a premium for a custom solution based on proprietary technology? And instead, customers started to invite combination of sort of specialists in some of them horizontal, some vertical, a combination of equipment vendors and developers to work together to develop solutions based on open systems, open standards that are cost-effective and future-proof because they're based on sort of open technologies. So that's one big change. And related to that, there's also sort of a change in the roles. So traditionally, when we talk about, especially technology industry, we talk about sort of, okay, here's a vendor who's selling their technology to a customer, so who's the buyer? But increasingly, especially as a line of business executives are becoming the buyers of the technology, they increasingly come to the vendor community and say, I don't want to just buy your solution. I want to co-innovate with you. I know exactly what my problems are, and I'm expert in my business. You are experts in your technologies. Let's work together, co-innovate to have the best of both worlds. And how to do it in a smart way, not as a custom solution, but as a repeatable model, has been one of the big lessons learned as well. It's funny because we talk a lot about Internet of Things, but really IoT is about people. And sort of changing how you think about your workforce, how you hire, where you hire, what skills are required, is probably the biggest part of the IoT transformation. And I sort of think of these in sort of three buckets. The first one is leading IoT adopters actually sort of change completely the way they approach their workforce. Again, I've lived in the technology industry all my life, and for example, I've been at Cisco 18 years, and I've had 7 different jobs. Even in this current job, what I'm doing now versus 4 years ago when I started is completely different, and the tools I use are completely different. So I'm sort of used to this concept of constant learning and recreating sort of my job and my skills. But in many of the more traditional industries, the prevailing sort of approach was, okay, I start a job, I stay in the same job for a long time, the job doesn't change very much. But then again, with IoT, now what we're seeing is that we need to actually change that mindset to the mindset, a culture of constant learning and sort of reinventing ourselves as well. So that's sort of one big change, where with IoT, you can't just sort of say, all right, here's a new solution. Let's just train our workforce on this new solution and we're done. It's the mindset change, right? I can give you maybe a couple of quick examples. The first one is a company called Campo Frio. They're a meat packaging company in Spain. And they had a sort of disaster. One of their plants actually burned down. But what the company did is they went to their workforce and said, we want to sort of create a state-of-the-art, fully automated plant. But don't worry, each of you will have guaranteed job in this new factory. But let's work together to create this factory of the future. So as a result, they actually had their workforce on board, and the employees were not thinking of this and looking at this as a potential threat to their job, but they thought about the opportunity to grow their skills and to create this new factory. And then 2 years later, they opened up this new factory. Most of the people that worked in sort of in the more traditional, more manual sort of way in the factory, in the process, upgrade their skills to become now quality managers and supply chain experts and so forth. So it was a win for the company, a win for the workers as well. They had sort of improved skills that actually made making more money in the process. Another example. So I live in the Bay Area in Silicon Valley, but there's another valley 1 hour south of Silicon Valley, and we sort of call it Lettuce Valley. So actually, most of the packaged lettuce that we consume in the U.S. actually is coming from Salinas and the neighborhood. So recently, I visited one of these plants, and these packaging sort of plants, and on one side they had a fully manual assembly line. On the other side, they had a fully automated line. So on the left, you had 20-some workers working on the assembly line. On the right, you had 2 people working on the line. But the same thing, with a shortage of workers, the company, as they are upgrading their line by line, they've been also working with their employees to upgrade their skills. So moving from being a manual a person working on the line, they've been upgrading their skills to now becoming more of the, again, quality engineers or supervisors and so forth. So hopefully you're getting the picture, is that you have to take your workforce with you, but at the same time, if you do it, you can come up with these win-win sort of scenarios. The second one is around building relationships. You know, in the US and Western Europe, there are tens of thousands of manufacturing jobs that don't get filled every year because we can't find qualified people to actually do these jobs. So what the companies are doing, and there's a great example of a new manufacturing alliance in Wisconsin that brought together educational institutions and manufacturers, and they are designing curricula together. So as a result, they're getting more qualified candidates. Instead of getting a generic data scientist, they're getting this data scientist that actually knows their industry. So these kind of win-wins actually work very well. And also, you need to get more creative, like apprenticeships, very popular in Europe. They're actually having a comeback in the US. US government a couple of years ago actually dedicated, I think, a $100 million fund to actually promote apprenticeships as well. And probably the last trend I wanted to highlight is IoT is also enabling a shift to a new business model from the sort of traditional product-centric business models to service-oriented business models. Why? Because now that the data is flowing, you can make a more intelligent decision about maybe instead of building a plant and operating a plant, you just buy the capacity and you use only what you need. And the savings go straight to the bottom line. And as you can see from a technology perspective, IoT is not just a technology trend in isolation. We've already talked about IoT and artificial intelligence, like with preventive maintenance. We're starting to see IoT and blockchain use cases. Recently, there was Trusted IoT Alliance created that is working exactly on how to implement blockchain in IoT. Fog computing or distributed cloud. A lot of the use cases that I've talked about actually require some of the cloud capabilities to be taken close to the edge, and processing of data. For example, in connected vehicle, when level 3 or 4 driverless vehicles, they would generate 3 to 4 petabytes of data per year. You can't just send the data to the cloud. You have to process the data locally as well. So maybe a few more points before we open it up for questions or comments. If you look at sort of IoT, it's hard to talk about the state of IoT without security. And it's sort of interesting because we've gone through a huge transformation. But my key message is, and I overall would sort of give IoT security a C- grade. But the good news is that, especially over the last year, we've seen a lot of progress. And there was a silver lining from these IoT denial of service attacks from a year ago. It suddenly, pretty much every security vendor started to invest appropriately into the IoT security areas. We still have challenges with device manufacturers, especially consumer device manufacturers. Sort of similarly to what we had 15 years ago with Wi-Fi. We need to continue to educate these folks that obvious things like putting default name and passwords into hard-coded into your device is not a good idea. But we're making progress there. So I would say that the industry over the last especially 12 months is making a lot of progress in terms of standardization, in terms of sort of interoperability and certifications as well. Not sufficient, but we're starting on the journey. I will also say we're making a lot of progress on the business side as well. So, a couple of years ago, when I was in Hanover Fair for the first time, the prevailing mode, let's say, in the industrial world was this concept of security by obscurity. My plant is not connected to the outside world, thus I'm secure. But I think people have found that this was a sort of very naive approach, and they found that when they started looking into using sort of discovery tools, that there's a lot of virtual private networks from vendors, contractors going into their plants already. We saw that most of the use cases that we talked about required the data to flow from the plant to the enterprise to the cloud. So we started to see that companies are aggressively moving from this sort of security denial to now having a comprehensive approach with security. They're inviting their CISO, chief security officers, to actually own the entire architectures. The Verizon study showed that majority of most recent security incidents were leveraging known vulnerabilities, like Windows systems that were patched many years ago. But if you didn't patch that system, then you were exposed. So the first thing was, in many ways, if you work with your CISO organization, rather than rediscovering the wheel, you can leverage sort of the best practices in terms of network segmentation, role-based access controls, and discovery, and so forth. So what we're seeing is that businesses are now implementing policy-based comprehensive architectures that focus on before, during, and after capabilities. We're also seeing businesses training employees about the best practices, not only digital security, but also physical security as well. But at the end of the day, it is everybody's responsibility. Yes, it's vendors. Yes, it's businesses. Yes, it's employees. But it's also us as consumers. If you're installing a camera in your baby's bedroom, you still should be able to check. Okay, are there sort of obvious security challenges like default name and passwords? So bottom line, we're making progress, but still we have a long way to go. And the last thing I wanted to highlight is standards. When the original internet was standardized 20, 30, 35 years ago, we were sort of lucky. We had a couple of standard bodies, IETF, IEEE, that we basically used to standardize major internet protocols. IoT is not that simple. IoT is not one market. There's a collection of markets and sub-markets and ecosystems within these markets. There are literally hundreds of standard and semi-standard bodies within these ecosystems that are working on different standards. So again, we're making progress in standards, but we're not there yet. There's good work in horizontal standard bodies. Like, for example, time-sensitive networking is being used to evolve Ethernet standards to make them Ethernet more appropriate for sort of deployments in plant and industrial sectors. We're working with major industry bodies like ODVA, ISA, and so forth, to a combination of horizontal and vertical specialists to evolve their legacy systems into the open standards. And there are also consortia like IIC consortium that is working on the interoperability, or Open Fog consortium driving standards around fog as well. So overall, again, making progress, but there's still open issues with standardization, for example, of data framing coming from sensors and so forth. So overall, if I look at the state of the industry, my latest blog, I sort of gave the industry sort of a B-. We're making progress, but not enough to make it really easy for all of us. But if I think about it sort of like, how do we all get started on this IoT journey with all of these complexities and all of these challenges? I'm often asked this question, which is the reason I wrote the book. But I also sort of created and centered the book around this, what I call this recipe for IoT success. If you are an organization who wants to implement IoT, or even if you're a vendor or application developer, you need to understand that you need to take a comprehensive approach to IoT. And here are some of the items that you need to pay attention to make sure that you are successful in your IoT journey. I'm not going to go through all of them, but we've mentioned some of them, like build partner ecosystem, integrate technology solutions with business process. So in summary, if you've already started on the IoT journey, congratulations. But if you haven't, please do so. How do you do this? Three things. First of all, don't be a hero, don't reinvent the wheel. Pick one of the 4 fast paths to paybacks that I've highlighted earlier. Because your peers, and literally tens of thousands of your peers, have already done those, so you can learn from their experiences. Learn from your peers' mistakes. I've listed some of them already. And use my recipe of IoT success as sort of your guide to make sure that, that your first project is successful, but you also then charted your IoT journey for success. So I wanted to welcome all of you to Generation IoT, and I hope that all of us will be participating and driving the IoT agenda over the next couple of years. So let me pause here and see if you have any questions or comments. What's the name of the book, please? The book is called Building the Internet of Things. And you can pretty much buy it anywhere. What you would find in the book is there is not a lot about technology, although I talk about security and standards, but really focusing sort of on the business aspects of IoT and how you can successfully start your IoT journey. Any examples of companies working with universities to develop IoT curricula? Yes, so I can give you a couple of examples. So at Cisco, we actually have a network academy, and we've been working on network academy with universities. I know that for example, University of Wisconsin has a IoT curriculum as well. I've seen online IoT curricula from Audacity and IBM and others. So, so there is actually a lot of curricula that have been created. I'll let you in on a secret. I've actually been working on a sort of a workbook companion to IoT book that will also sort of help people navigate and get started on IoT journey as well. You can also reach me at mkranz@cisco.com. You can also go to my website, www.maciejkranz.com, where you can get some more information as well. All right, thank you so much. Thank you, everybody, and hopefully you are as excited about IoT journey as I am. Thank you again.